Okay, let's take a look at class example problem unit B2 page 7. This is a barometric pressure head problem. Let's take a look. Barometric pressure of 29.4 inches of Hg corresponds to what value of atmospheric pressure in psi and in pascals? Okay. Well, this is barometric pressure head. Okay. So somebody says today's atmosphere, p07 today, is 29.4 inches of mercury. Then you usually say, what? What are you talking about? 29.4 inches of mercury, that's today's pressure here. This is obviously not the pressure itself, it's called pressure head. Okay? So remember the barometer, which is a device oftentimes we use to measure atmospheric pressure. Now, let me just show you just a schematic of that device. So suppose you have this is a tub of mercury, Hg, filled up with Hg. You're going to stick the glass tube in. Then what you usually do is you are going to remove all the air out. Making it complete vacuum. We can never make a perfect vacuum, but the pressure is low enough so that pressure becomes P vapor of Hg, which is P vapor of Hg is, let's look at the previous page. So P vapor of Hg is 0.000023 psi, which is right here. So this is near perfect vacuum, which is not, but it's very, very low pressure, which is going to instantaneously change the liquid mercury into gas vapor mercury. Vapor pressure is achieved. So this is what? 0.000023. psi, yeah, okay. At 68 degrees F. Mercury. Okay, if you create such a condition, you're going to allow Hg within this glass tube rise up certain height, this much height. That H happened to be 29.4 inches. This H is caused by simple fact that the surface of this liquid is pushed by atmospheric pressure, p07. So that's why you ended up being this much height, H. It happened to be 29.4 inches. So this actually measures what is p07 for a given location. Okay? So question is, okay, what value of p07 in psia corresponds to 29.4 inches of mercury? If somebody says p07 today is 29.4 inches of mercury, that person really says that p07, whatever it is, divided by specific weight of the mercury, is essentially 29.4 inch. That's the meaning of this statement. Okay, assuming that this is zero, absolute, close to zero absolute, which is very, 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 very low value. Okay, so due to the fact that from here you can say what is p07, the pressure itself, which is 29.4 inches multiplied by the specific weight of the mercury, in which you can look up in the table. Okay, so for a given standard condition, specific weight of the mercury is 847 pounds per cubic foot. This is inch, so I don't want to use inches. So before you multiply that, you're going to convert it to foot. 1 foot over 12 inch. Then multiply by 847 pounds per cubic foot, which is that. This is going to give you 2,075.15 pounds per feet square. I don't like this, so let's convert it to PSI. 1 feet over 12 inch square. This is going to give you 14.41 PSI. This is always absolute because this is atmospheric pressure is always absolute, right? So I would say PSIA, but you don't have to say it because this is PATM, always absolute. Okay. So if somebody says 29.4 inches of mercury, you can convert it to 14.41 PSIA, which is, this is the pressure. This is actually not the pressure, this is pressure head. Okay. Now, note, in pascals, this is equivalent to 99.35 kilopascal. So, this pressure head expression is very, very useful and meaningful. Later on, you're going to find out. Now, typical expression of, for example, wind tunnel. Wind tunnel. Wind tunnel test section airspeed. You can actually try this today if you want to. You just visit wind tunnel lab and then grab somebody who's doing wind tunnel testing, could be a senior student, whoever it is, then you can ask, okay, how fast this wind tunnel can go. The answer typically is 10 inches of water. $10 of water, that's how much you can go. Well, I'm asking you how fast this wind tunnel can go. Well, I'm saying 10 inches of water. What is that? So this is going to be covered later, but this is again similar expression, pressure head. So there's a reason why you cannot directly answer miles per hour on the wind tunnel test section airspeed. That's why people use 10 inches of water instead. This is necessary. You cannot guarantee 100 miles per hour, but you can guarantee this for this particular wind tunnel. Okay? You're going to find that one later. So let's do one more practice here. So somebody says today's PATM, atmospheric pressure, is 29.4 inches of mercury. So you can say, so how much feet of water do you have? No. All right? So in terms of feet of water, PATM divided by gamma H2O. So you can do 14 point, actually no, this one. 2075.15 pounds per feet square divided by gamma H2O, 62.4 pound per cubic foot. This is going to let you have 33.5 0.26 feet of water. So this is the equivalent expression. If somebody says 29.4 inches of mercury, you can say, well, do you mean this is 33.26 feet of water? It is the same meaning. It's just a different expression using different type of liquid. So this is expression of pressure head. Pressure head, you're going to run it, especially at pipe flow analysis. Pipe flow analysis, we are going to apply equations based on the head. Head is, if you have a vertical pipe, how much liquid column you're going to get. That's called head. Okay, so it's an equivalent expression of the pressure in terms of liquid column height in the vertical pipe. We're going to run that later. Okay, so that's it.